Welcome back everybody to another video lecture from Miss Semino. Today's lecture will be talking about the history of the periodic table, and this goes along with your 6.1 fill-in-the-blank notes. The objectives for this lesson include explaining how the periodic table is organized, describe how early periodic tables were organized and how we currently organize the periodic table, and discuss the three broad classes of elements on that periodic table. In early human history, we only knew about a few elements, particularly gold and copper. By the year 1700, we discovered about 13 different elements, but as our science kept getting better, we were able to discover more and more elements. As we discovered more elements, we needed a way to organize them or to be able to reference them. Over the years, as more and more elements were being discovered, many different people tried to organize these elements into different tables. It wasn't until Mendeleev came along in the mid-1800s. At that time, we had about 70 different elements. He is credited with creating the first accepted periodic table. Mendeleev was a Russian chemist and a teacher, and he arranged the elements in order of increasing atomic mass. And the one thing, since it was the 1800s, he didn't know anything about subatomic particles, so he was really just organizing them based off of their properties. In Mendeleev's periodic table, it was really awesome because he left some blank spaces for undiscovered elements. Like I said, he was organizing the elements based off of their properties, and so when the elements were discovered, we saw that he had made good predictions about them. There were, however, a few problems. Cobalt, nickel, argon, and potassium don't really fall into the typical categories, and we'll talk a little bit more about this in class. So while the first periodic table is credited to Dmitri Mendeleev, his periodic table, remember, was organized by atomic mass, and we currently organize our periodic table by atomic number. And so this new arrangement, or a better arrangement, came about from Remos Lee. And like I said, he organized the periodic table by atomic number. This is the arrangement that we use today. So when we look at the periodic table, the first thing that we need to talk about are these terms groups and periods. So a group on the periodic table is one of the columns. So there's one group, here's another group. And then the periods are the rows that we see on the periodic table here. So 2 rows right there. Those are 2 different periods. Now when we talk about the periods, we like to go ahead and number them. So it's pretty simple. This first period includes hydrogen and helium. So this is period 1. Lithium, beryllium, all of these guys right here. This is going to go ahead and be period 2. Period 3, 4, 5, 6, 7. Now that I've made the periodic table a big mess, we still do need to look at a couple of other things on here, and these are the group names. So this first column over here, this is actually called the alkali metals. This next group that's already marked for you, this is called just the alkaline earth metals. Then all the way over here, notice how the halogens are this column right here, and then the noble gases are this final column right here. And we'll go ahead and we'll talk about some of the properties in class of these, but basically alkali metals are really reactive, alkaline earth metals are a little bit less reactive, halogens are very reactive, and then remember noble gases, they have When we describe the arrangement of the periodic table, we say that it follows the periodic law. And this says that when the elements are arranged in order of increasing atomic number, there's a periodic repetition of their physical and chemical properties. So like we said, the horizontal rows are called periods, and there's 7 periods on our periodic table, and the vertical columns are called groups. Sometimes we'll refer to them as families, and what we should know about these groups is that they share similar physical and chemical properties. So when you guys are making your periodic table basics activity, that one where you're cutting and pasting those element cards into your notebook, I'm hoping that you're noticing a couple of things so that you'll be able to answer these 2 questions. So the first question here says, what do all the elements in the same period have in common? And it says, hint, look at the electron configurations. So hopefully you're noticing that all of those elements in the same row end in the same energy level. So if you remember, we were talking about the rows. If you're in the 4th row, your final highest electrons are going to be placed in the 4th energy level. If you're in the 6th row or 6th period, your highest electrons will be in the 6th energy level. And then, what do all the elements in the same group have in common? So hopefully you're noticing that they all have the same number of valence electrons. And remember that valence electrons are really important because those are the ones that give the properties to the elements and determine which elements will bond with which other elements. So finally, we're going to go ahead and get into the three main classes of elements. These are metals, nonmetals, and metalloids. So for each of these, you'll need to know some different properties. So metals are electrical conductors, they have luster, they're ductile, and they're malleable. So two words that here you might be a little like, about are ductile. So ductile means that you can string it into wires. Malleable means that you can take that metal and form it into different shapes. Nonmetals, these are generally brittle and non-lustrous. They're poor conductors of heat and electricity. So notice that they're just opposites of metals. And finally, we have metalloids. You should hopefully notice a heavy stair-step like dark black line on your periodic table. Normally we'll find metals on the left-hand side of that and nonmetals on the right-hand side of that, but metalloids, they border this line, so you'll find them on both sides, okay? And metalloids have properties that are intermediate, and sorry you can't see this on the bottom here, between metals and nonmetals. So they have some properties of metals, but they also have some properties of nonmetals. So thank you for listening to today's lecture. Again, I'm hoping that you learned a little bit about the history of the periodic table, how it's organized, and then the three classes of elements on the periodic table: metals, nonmetals, and metalloids. See you in class.